Let's see for number 4 now. A stockbroker is trying to remember how the value of a stock changed over the past 10 days. The graphs below show the graphs for stock 1 and stock 2. The broker remembers that the slope of the graph that represents the value of the stock was less than the slope of the graph for stock 1 and greater than the slope of the graph for stock 2. Select each possible change in the values for the stock. And then we're just comparing these 4 options, which are asking us to find the slopes for each of these. So I think this is just easiest if we find the slopes of these 2 graphs in order to determine which of these answers are right. So let's take a look at this first one. Looks like we're going from 0, 8, and the next point that looks easy to read will be right here. So our 5, 12. So we've got 0, 8, and 5, 12 for our points that we can use to find our slope here. So let's take our slope, we'll call it M1 since we do have 2 graphs. 12 minus 8 over 5 minus 0 is equal to 4 over 5, which all of these are decimals. So let's convert this one to a decimal. 4 over fifths gives us 0.8. And now let's try our next one. So we've got same starting point here of 0, 8. And now this one, it looks like we've got a second point at 5, 10. That's nice and easy to read. 0, 8, and 5, 10. So now for our M2, we'll take 10 minus 8 over 5 minus 0, and we'll get M2 is equal to 2 over 5, which, as a decimal, we should be getting 0.4. So now, looking at our answers, well, our M1 referred to our stock 1, and this one says our stock 1 value increased by 80 cents each day. Well, that's what we found for our slope of our 0.8 or our 0.80. So D looks correct. Then for our number 2, we've got our slope 2 is equal to 0.4, which our letter C says the stock value of stock 2 increased by 40 cents. So it looks like C is right for our second stock option here, giving us C and D for our 2 answers that we want. Now let's try out number 5. So the graph below represents the elevation of a theme park ride over the course of the ride. Which statement does not correctly describe the graph? For this one, I'd like you to try and do this one on your own, so go ahead and pause the video for this one and see if you can determine which of these statements is not true. Once you think you've figured it out, unpause the video and let's go over it together. Alright, so let's take a look. We can say letter A, the ride started and ended at the same elevation. Well, it started at a height of 50 yards, and it looks like it ended at a height of 50 yards. So A is true. We can ignore that one and move on. Letter B, the ride was at a constant elevation for half a minute. Well, a constant elevation would imply that it didn't change height at all, which looks like this one flat region. It doesn't change height during this point in the ride. Let's see if that is half a minute. So we're starting at 90 seconds here, and it stays flat until 120 seconds. So 120 minus 90 is equal to 30 seconds, or half a minute, which would mean letter B is also true. So we can ignore these first 2 options. Letter C says the first minute of the ride, the elevation increased at 2.5 feet per second. Well, our graph is in yards and seconds, so we need to do a little bit of a conversion here to see if C is right. But let's take a look. We're starting at an initial height of 50 yards, which I can say, I'm just going to write that as the point using the value for feet instead of yards. So 50 yards is equivalent to 150 feet. So this point I'm going to call 0, 150. Now let's take out the second point here to find that slope for the first part of the ride. So this is at 100 yards, which we can say is equivalent to 300 feet, and that occurs at a time of 60 seconds. So our second point, we've got 60 and 300 feet. So now if we want to find our slope for the first part of this ride, let's take our 300 minus our 150, and we'll divide that by 60 minus 0, which is going to get us 150 over 60, which does in fact equal our 2.5 feet per second. Which, if we compare our units, we did have feet on top here for our slope and our time on the bottom here for our denominator. So it looks like C is also true. We've got 2.5 feet per second is how fast we're going up for the first bit of our ride. Now let's check out and just confirm that D is not true. So we have the last half minute of the ride, the elevation increases by 1.5 yards per second. So you can see we are going up there, so we are increasing by something. And now let's see if we are actually going by 1.5 yards. So we're starting off at the point 120 and 30. And 150 and 50. So now if we calculate the slope for the last bit of our ride here, we can take, that should be a 30. Do that in black. So we've got a 50 minus our 30 all over our 150 minus our 120. So this will end up giving us a 20 over 30, which simplifies down into a 2/3 here. So it looks like we're increasing 2/3 of a yard every second and not 1.5 yards. So that's going to make letter D incorrect, which is actually the right choice. So D is the one we're looking for here, because we do not increase at 1.5 yards per second at the end of the ride. It is 2/3 of a yard per second. All right, now let's check out our slope-intercept form and our point-slope forms. So let's go over a couple of more vocab terms. We've got our slope-intercept form, which we can express as y is equal to mx plus b, and our point-slope form, which we can express as y minus y sub 1 is equal to m times the quantity x minus x sub 1. I know this one's kind of tricky because we have the multiple x's and y's, but in this one, our plain x and y terms are our variables, and the superscripts are the actual point itself. So these will just be numbers that we're going to plug in later on. Then we've got our parallel lines, which have the same slope, and perpendicular lines, which have slopes that are opposite reciprocals. Now let's go over a couple of examples and put these into practice. Number 1, we're asked to write the slope-intercept form of the equation of the following lines. So we have these equations that are in our standard form. If we want to write them in our slope-intercept form, that means we need to solve them for y. So let's isolate this first one by subtracting our 3x on both sides. And now we want to get y all by itself, so we can just divide everything by that -2. And now we have our slope-intercept form, where we have our slope times our x plus our y-intercept there. For letter B, why don't you try this one out on your own, and then once you think you've come up with the right answer, unpause it and we'll go over it together. Okay, so letter B, it's fairly similar, where we want to subtract our x term from both sides. And likewise, we want to get a single y by itself, so let's divide out by that constant of -11, and we'll get y is equal to 12 over 11x plus 12/11. For number 2, we're asked to write the slope-intercept form of the equation of the line that goes through the given point with the given slope. So whenever we have a slope and a point, point-slope form is really easy to use to start off with. So let's use our point-slope form first, and then we're going to change it into slope-intercept form from there. So just like our point-slope form formula had said, we can take our y minus our y1, so that's our y term here of 2, and set that equal to our slope of m, which is 7, times the quantity x minus our x value of also 2. So now we have y minus 2 is equal to 7 times x minus 2. So if we want to solve this for y, the first thing I'm going to do is distribute that 7. So we get 7x minus 14. Now let's add this 2 to both sides to give us y is equal to 7x minus 12. So we end up getting our slope-intercept form by starting out with our point-slope form. So we converted that to get our 7 times x of our slope and then our intercept of -12. Now let's try letter B here. So we've got a slope of undefined and a point of 3, 5. Well, a slope that is undefined, we know must be a vertical line here. So we don't actually need to approach this problem in the same way. We know we're going to get a vertical line, and if we are given the point 3, 5, well, let's look at our x value here of 3. We know we'll have a vertical line at that value where x is equal to 3. So this one we can immediately just say x is equal to 3, and that's going to give us the equation for this line. If I want to make a quick sketch of it here, got our y-axis and our x-axis here. At 3, we'd have a vertical line which would contain the point 35 right here. It contains all the points of 3 comma something that go up and down along this vertical line, and our slope is undefined, so we can't write it as a numerical expression. But if we want to actually represent this graph as an equation, we can simply just say x is equal to 3, because at x is equal to 3, we cover the entire expanse of our y values there. So this one is a little tricky at first, but it's actually not so bad once we model it first to see what's going on.